In this lecture, we will see theories of failure. We will see how can we predict the failure of material. So basically, ductile and brittle materials. And this is very known fact that the failure of ductile materials occur at onset of plastic deformation, whereas brittle material, the failure occurs at fracture. Okay. So brittle materials do not show much plastic deformation, and they all of a sudden they fail. So the examples of ductile materials are the most of the metals and plastics, and brittle materials examples are glass and ceramics and also cast iron. Okay, though cast iron shows some negligible plastic deformation, but for designer point of view, we can consider cast iron as a brittle material. And this is a typical stress strain behavior of brittle and ductile material. We know this behavior. This point is yield strength, which can be considered as a failure point for ductile materials, and this is ultimate strength for ultimate strength, which is failure for brittle materials. And this yield and ultimate strength, they are determined from uniaxial tensile test. Now, given a uniaxial case in no, analysis or in real case, it is easy to predict the failure of material, because uh, in real case, if the stress is uniaxial, we can directly compare it with our material properties, that is yield strength or ultimate strength, from the uniaxial test, right? But in most of the cases or real cases, the it is not no, uniaxial, right? It is a complex state of stress, that is a triaxial state of stress, and predicting the failure under this complex state of stress is not that straightforward. So there exist many failure theories to predict the failure under a complex state of stress. Okay, and there is no universal, no applicable method available. Okay, that means there is no universal theory which works for all materials, because we know the brittle materials and ductile materials, they behave completely fundamentally in a different ways. So theories of failure which are developed for brittle may are not applicable to ductile and vice versa. Okay. So there exist many failure theories, and this failure theory, they work well under certain circumstances. Okay, as we said, these circumstances are the observations from the experiments. Okay, observation means observation in experiments, how the material fails. Okay, so these observations, for example, the brittle material, it is observed that the brittle materials are weak in tension. So when the theories of failure are developed for brittle material, we have to keep this fact into account. Okay. Similarly, ductile materials, the mechanism of failure, that is yielding in ductile material, is basically a shear deformation. Okay, so that means, in other words, the hydrostatic component of stresses do not contribute in yielding. So these are two key observations in brittle materials and ductile materials, and based on these observations, the failure theories are developed. Now, as we said, like no, why we need a failure of theories, theories of failure, because we want to find the failure in complex state of stress. So, what do these theories do? So, they allow us to predict failure of material by comparing this complex state of stress, okay, or triaxial state of stress, with our uniaxial state of stress, or material properties from uniaxial tensile test. And the state of stress, we know it is arbitrary state of stress. We can define like sigma ij, which will have six stress components. But the stress state, okay, at a point can also be described using three principal stresses, right? We have seen this in concept of stresses. And therefore the most theories of failure, they are expressed in principal stresses and obviously material strength, that is yield strength and ultimate strength. So with this, let's see the theories of failure. Okay, first we will see the theory of failure for brittle material. And as we said, brittle materials are weak in tension, so our theories of failure should comply with this key observation from the experimenter. Okay, and this theory states that when the maximum principal stress sigma 1, when the maximum principal stress at a point reaches the ultimate strength of material, it fails. Okay, so if you see this max principal stress is basically largest, we know it's largest normal stress. Okay, and we know the brittle materials fail in, they are weak in tension, so they fail in largest tensile stress, that is nothing but max principal stress. So we are complying with the experimental observation. So it's a very simplest theory of failure. It simply states that maximum principal stress, when it is reaching a ultimate strength, the material brittle material fails. In the next lecture, we will see theories of failure for ductile material. Basically, there are two popular theories of failure for ductile, that is uh, von Mises theory and Tresca theory. So we will see it in next lecture.